Hallo zusammen. Vielen Dank, dass ihr alle da seid. Willkommen im Mindspace. Wir freuen uns so sehr, dass ihr euch motiviert habt und gekommen seid. Und natürlich würde ich ein bisschen über Mindspace erzählen, damit ihr auch wisst, was das ist, wo ihr seid und vielleicht habt ihr dann später ein paar Fragen. Also Mindspace, wir sind neues Coworking Space in München, aber nicht nur in München, wir sind auch in Berlin, in Hamburg. Wir kommen selber aus Tel Aviv, wir expandieren sehr stark und wir bringen neue Konzepte vom Arbeiten in die bayerische Hauptstadt. Das heißt, unter anderem versuchen wir Startups zusammen mit den Corporate-Firmen unter einem Dach zu vereinen, was für euch, die Techie-Genies, auch vielleicht interessant sein kann. Wir organisieren jede Art von Events bei uns im Mindspace, was auch interessant sein kann, relevant sein kann, weil es sind größere und kleinere Events und das heißt, dass man hier sehr gute Kontakte knüpfen kann, sich präsentieren und einfach gute Zeit haben. Heute haben wir einen Event, das von einem unserer Mitglieder organisiert wird, und zwar von Colliquio. Colliquio ist einer unserer ersten Kunden. Wir freuen uns sehr auf ihn und deswegen freuen uns noch doppelt, dass ihr, also Colliquio, dass die so viele Leute mit hierher bringen, dass sie so aktiv in Tech-Startup-Szene in München sind und dass sie auch Mindspace damit mit rein aufnehmen. Also wir machen keinen Applaus, aber Thorsten, oder wie wir ihn nennen, Totti, ist ein ganz toller Mensch, kennt sich super aus mit unterschiedlichsten Themen und der ist der Organisator von heutigem Event. Bitte.
Danke, Jana. Kurze Frage, ist Deutsch in Ordnung oder soll ich auf Englisch umschalten? English? Okay. So first of all, thank you, Jana, from Mindspace, our host of our company and our first office here in Munich. And of course, I'm not only the organizer of this day, but Larissa here in the back. Larissa, thank you. Of course. Who is Colliquio? We believe that every patient deserves the best treatment, the best therapy available. And we figured out that the best way of ensuring this is to provide physicians with the right information they need to treat this patient well. That's why we created a platform where physicians and the pharmaceutical industry can change information, can change ideas, and this is Colliquio. We are a platform for doctors, basically. And today, one of our developers from Lake Constance, now here in Munich, will tell you about Houdini. So a warm welcome for Thomas.
Thanks, Totti, and thanks again, Larissa, for organizing all this, and thanks to Mindspace for providing this beautiful location. So this talk is going to be about CSS, so if you're not interested in that, if you haven't read the description, this is the time to leave. Other than that, let's start. But the talk is slightly mislabeled because we're not going to talk about layouts only, but we're going to talk about a lot more than that. Layouts are one part of it, we're going to definitely hear about that, but Houdini is much more. My name is Thomas. This is my tech stack, or Colliquio's tech stack. I'm a front-end developer, so I work mostly with JavaScript, React.js at this moment, Sass, Docker. What else? Well, Git, GitLab. We deploy in the cloud. We use microservices. All the cool stuff. We have it. If we don't have it, we're gonna have it pretty soon. So, time travel back to 1996. This is what web markup looked like at that time. So you see a lot of presentational elements and attributes, line breaks, table markup, again, presentational attributes. And This is taken from one of my favorite websites, the agilemanifesto.org, which is, it's got to be one of the best websites because it has been unchanged since 2001. And so the markup is kind of the 90s style. And at some point in 1996, people came to agree that this is not a good idea to write HTML sites. We may need some separation of content, style, and behavior. You've probably all heard this before. This is what we teach young web developers when they get into the business. Please separate your stuff into HTML, CSS, and JavaScript. But in 1996, JavaScript had only been just invented by Brent Nike, an engineer at the Netscape Corporation. And CSS just wasn't there. So people tried to figure out ways to declare their styling in a separate language. And Brandon Ike and his team said, why not use JavaScript for styling? So they invented JavaScript style sheets, which is pretty cool stuff. Looks like this. This is an excerpt from the proposal. You can see that some of it looks familiar, but some of it doesn't. Everyone's favorite, the with operator. And yeah, this is the whole JavaScript language is being used to style the document. So you could have stuff like variables. As you can see, I'm defining a variable called mobile background. So, of course, we can do responsive design, even though there was no mobile devices at that time that could be used with that. But it was in the first version of the JavaScript style sheet language. But this standard never made it because Microsoft decided not to implement this stuff. Instead, they proposed CSS. And you all know CSS. So CSS won because Netscape also implemented CSS. So JavaScript style sheets died. Fast forward to 1999. At that point, Microsoft said, wouldn't it be cool to use JavaScript for styling? So what they invented was HTML components. And you've probably seen the PyHTC. So PyHTC, this is something where you just define a behavior in your CSS. And then there's this HTC file, an HTML component file, which basically contains a lot of JavaScript. Event listeners, script, and just ignore this stupid hack that even makes it work in Internet Explorer. But HTML components were there in 1999 and died, I think, with Internet Explorer 10. So if you think HTML component, that sounds familiar. Yes, it does. It all comes back some 10, 15 years later in the form of web components, which you've probably heard of. But we're not going to talk about that now. In 2006, some guy called John Razik thought to himself, wouldn't it be cool to use JavaScript for styling? So he provided jQuery, and the very first version of jQuery already had this animate method where you could just plug in some height or some CSS attributes, and it would modify the DOM and then provide animations that hadn't been there in CSS at that point. Also, you could do stuff like add event listeners that reacted to user behavior. So, for example, here is a scroll listener that would kind of dock some sticky element to probably to the top of the window. We all know this as sticky headers. And we still use that stuff today because there's no better way to do it, right? So use JavaScript to listen to user input, to listen to events, then modify the DOM and hope that the browser does something useful with that and it looks like we want it to look. So it somehow seems to me that our original model is kind of flawed. Maybe style and behavior cannot be separated completely from each other. And there's basically two solutions for this. So one is use JS for styling, but we really don't want to do this because it is very slow. So you've all seen performance optimizations where people tell you how to write effective code that gives you 60 frames per second, etc. And second, the APIs are awful. All we can do is modify the DOM, and we can modify the CSS tree as well. We're going to see that later. But those APIs are really crap for styling. So the second approach is, well, just give us more CSS features. Make CSS more dynamic. Give us the behavior that we want. So, for example, CSS transitions and CSS animations were a big step forward in that direction. But it takes ages until those features arrive. The standardization process can take 5 or even 10 years before we can even use that stuff. And the web is developing rapidly right now. So mostly people nowadays talk about the web platform. So we're thinking about the web as an operation platform where we want to write applications. We don't want to write websites. And CSS was never designed for applications. It was meant for websites. So even when a new CSS feature comes up, the designers and developers have thought about more things they want to do right now that is way ahead of that. For example, border radius. At the point where border radius was implemented in all browsers, nobody wanted to use it anymore because styling went to rectangular. So another problem with CSS is it's too static. There's no dynamic evaluation in that. So yeah, you can use tools like Sass and Post CSS and LESS and all this stuff, but that will just run at build time and generate static CSS code. So no dynamic evaluation there. And the other thing is, the more CSS features we get, the more complex CSS gets. So when you're learning web development today, it's already a whole lot of stuff you got to learn. And it gets more and more and more. And writing CSS is very complicated because basically what we do as web developers is try and turn this into this and this. So at the same time, constantly thinking about what the browser is going to do with that stuff. And what the browser is doing is it takes 2 strings, HTML, CSS, does some magic tricks, and produces some image. That's what's happening. And I can prove that because there's a website that is completely dedicated to that, csstricks.com. You all know it. And this just teaches us what tricks the browsers do internally. It's crazy stuff that happens. For example, like this one. If you haven't seen this before, you've never seen CSS. This is just ridiculous. Why do we need stuff like that? Well, the reason for that is the browser actually, it does some hard work. Well, this is craftsmanship. It's not magic. It does work. And when you take the time to look into the documentation, into the specification of CSS, this is CSS2. This tells the browser how to lay out a page. Well, and there's the next page that provides some details. So it's really hard work, and browser vendors implementing that stuff have a lot of room for bugs, but basically they all do the same things. So all browsers basically work the same because it's written in specs. So let's for a moment imagine we want to write a browser. This is what we have to do. Take HTML and CSS and parse that stuff, which generates a parse tree, which is then turned into a model. This is better known as the DOM tree, but I think that is bad naming, so it's more the element tree. And CSS is turned into a style tree. Then those 2 trees get combined into a render tree. And up to this point, there is no painting happening, no drawing. This is all just abstract representations, and this is what happens in browser mocks, for example. Once the render tree is created, the browser needs to figure out how to lay out the elements on the page. Where do all the floats go? Where do all the position fixed elements go, etc.? This creates the so-called box tree. And then it starts doing the actual painting. Background images, borders, text colors, box shadows, images, all that stuff. But it doesn't do that as one image, but it creates multiple layers that then get sent to the graphics card and get blended together. So this creates effects like opacity, CSS filters, and transforms. This is done by the graphics card because the graphics card is highly optimized for that. So today we have a couple of APIs that allow us to interfere with this process. Best known is the DOM. Not so much known is the CSS DOM, which is basically the same, but not for the document tree, but for the CSS tree. We have a DOM parser, and then we have a couple of getters that are, getting some of that results here. But notice that from this point on, we cannot really set anything. We cannot interfere with the browser's rendering process. So all we can do is keep modifying the DOM all the time. This means that when we set, for example, when we set a style attribute, the browser has to go through all these steps again. And this is very, very slow and kind of magic. So some developers, let's say some engineers at the W3C said, this is not perfect. We need a better way to do this. So they wrote the Extensible Web Manifesto, which basically states two things. First of all, we want to explain the browser magic to people, to the public, to developers, people like us. And second, we want to provide the possibility to teach the browser our own magic tricks. And if you read the Extensible Web Manifesto, you will not find the word magic in there. That is probably a translation error, but they're talking about low-level capabilities. But what they really mean is they want to do magic, because it doesn't. So those guys decided to found the World Wide Web Consortium Cascading Starship Technical Architecture Group Houdini Task Force. This is one word. In short, CSS Houdini. So there it is. It's a group of people who decide to bring the web forward by developing CSS further. This is their website. Part of it has been shifted to the WICG, the Web Platform Incubator Community Group. So if you're interested in their current progress, check out these websites. What exactly are they doing? So they had a look at this, and they just said, we have no APIs here, nor here, or here, or here, or here, or here. Let's just create APIs for that stuff. So this is what they're currently working on. There's APIs for basically every step in the rendering process. They're even working on improving the CSS object. And before we get into that, there's this beautiful website called Is Houdini Ready Yet? That tells us about the current state of the implementations. And you can see that Google Chrome, of course, has most of it implemented partially, or has plans to do so. So when I tried to work with that and get it running, I found that the type DOM works, the getters work, the setters don't. Properties and Balance API works pretty well. Custom paint, yes, partially. Oh no, not partially. It actually works right now. But animation, I couldn't get animation to work. So there's polyfills for that. And, there's even stuff that hasn't been implemented by anyone. But the interesting thing is that these browsers up here represent also members of the CSS Houdini group. So basically everyone is involved in defining those standards. So there's hope that we can use this without any cross-browser bugs, because they all work together to define those standards. So as nothing of this is really ready to use, let's fast forward to 2022, 5 years from now. Let's see what the web will look like in the future. And we're going to go through that in order. First of all, the CSS parser API. So the browser needs to read the CSS, parse it, And I've already mentioned the DOM parser API. This is for comparison. When you plug HTML into the browser, the DOM parser runs. And right now, as per today, we have the possibility to trigger that manually. DOM parser parse from string, put some HTML into there, and it returns an HTML document. So why not have the same thing for CSS? And Houdini defines this. CSS.parseStyleSheet. As you can see, this is asynchronous. If you haven't worked with the await keyword yet, just imagine this returns a promise. And you plug in some CSS, and it returns an object that represents the parse tree of that CSS. I've taken this from the draft of the specification, and I wonder if this is intentional. You see that there's no margin top here. It says margin top at the bottom. Probably just a blunder, but the parser shouldn't do that, I guess. The interesting thing is that it decomposes this value here into a value and a type. So yeah, that's good stuff. We're going to see this later on again. Next thing they developed is the Properties and Values API. So this is just a natural evolution of custom properties or CSS variables as we know them today. So this can be used, unless you support Internet Explorer 10 or so, you can use CSS variables. This is what it looks like. You just define your variables. Just like for people who've worked with SAS, imagine there's a $sign here. So define your variable and use it by using the var keyword. The problem with this is that these are strings. And if I do something like this, the browser will happily parse this, plug it into here, and throw an error at this point. So I cannot tell the browser to ignore this little part here. So the CSS Properties and Values API gives me the ability to tell the browser what exactly this variable should be. So it's named bgColor. I can define inheritance, give it an initial value, and define the syntax. So this will be treated as a color value no matter what. And if I try to plug in 12 pixels here, it will just get ignored. That's the idea, but actually in the current implementation, this is not working. What is working, however, is animation and transitions. Because now the browser knows that this is a color, it can actually transition between two color values, which is not possible between two strings, because how do you translate between two strings? So, for example, define a button color red, give it a background button color, and have that given a transition. So, button hover should get a color of green. So when I hover over the button, this will just get plugged into this value, so the background will turn green, and also this transition will apply because I've declared this as a property, as a color value. So this is actually working. I'm running this in Chrome Canary. So pretty cool stuff. Next thing is the type object. So when you try to set styles using JavaScript, you probably end up just doing something like this. You combine strings, add some px or em or percentage or whatever, pass that string to the browser, and the browser will have to go ahead and decompose that stuff to find out what the actual value is and what the unit is. Also, the reverse applies. If you try to get some style, for example, the width, you get a string that has been produced by the browser, but you're going to have to decompose it by just stripping off the unit or whatever and parse it as a number. And this is very wasteful. So what the type domain offers us is new types. So for example, the CSS number type or the CSSPX type. And one of two cool things about this is that when you get that stuff, it already decomposes it, so you don't need to parse any strings, but you can just access the value property of this. And the second cool thing is that this speeds up animations considerably. The Chrome dev team have run tests in animation-heavy website, and they have been able to speed up animations by up to 90%. Because string parsing is so wasteful that if you eliminate the step of string parsing, it gets really fast. The problem with that is, of course, you're going to have to write more code. So to get more performance, you need to write more code. For example, a calc value will get decomposed into this monster. Next thing is the cascading API, which I have nothing to offer about because no work has been done on it yet. That is why the cascade is frozen. But let's just enjoy this beautiful picture. Remember that latency coming. Okay. Next thing is font metrics. And I'm going to provide an example of an actual project of mine, where the designer gave me this little screen design, and he wanted to have the text cut off in the second line and just naturally web on the first line. So it should always be exactly 2 lines, no matter how long the text. Okay, easy. In order to get this, we need text overflow ellipsis, overflow hidden, and white space pre, I guess. But when I put white space pre in here, it will not wrap here. So this is kind of weird. It looks very simple, but it cannot be done with CSS. So what we ended up doing was render that stuff off screen, measure how wide it is, keep cutting off one word after the other until it fits into one line, and then just produce 2 spans. It worked, but it was awfully slow, which didn't matter, but there will be a better way to do this. The font metrics API tackles exactly that problem. You can just throw in any element into the document measure element, or even measure some text, providing some styles, and the easiest way to create a style object is just using some element that's already on the page. So for example, if you have some cards containing some text and you want to create a new card that looks exactly like the other ones, you just measure your text using one of the cards that's already been rendered. And this will return an object containing a lot of information about this element. Particularly advances. This tells you where exactly each character of the text is on the screen. So this would be, the second letter would be 12.5 pixels from the left. So you can decide how far this element or this text will run. There's also information about fonts, because if the browser doesn't find certain characters inside the string in the given font, it will take a replacement font. So this will tell you what fonts have actually been used. It tells you where the baselines are, and a lot more. So this will allow more precise designs, which means more work for web developers, for front-end developers. Next thing is the box tree API. So just like the books here, when the browser renders a website, it lays out text in boxes. And it is sometimes difficult to find out which part of the boxes have which dimensions. Because, for example, inline elements may be split into 2 separate parts, one at the end of the line and one in the beginning of the next line. Or you could have something like first line, first letter, and at the moment there's no API that gets you these elements. Boxtree API solves that by just providing this get fragment information method. And you can decide whether or not you want to include the hierarchy. So it returns a simple object containing some information. I think it's not too exciting, but it's there. So, short summary, intermediate summary. So, we have looked at some of this, and we haven't yet looked at these three. And these three are actually the more exciting part of Houdini. Because what we've seen so far are APIs that just get data or set data. But these things will allow us to modify the browser's behavior. So the idea is we can actually, as developers, decide how the browser does its layout, how it does its painting, and how it does its compositing. So it's like a plugin system for the browser where we as web developers get to decide what the browser does. So basically, we can use JavaScript for styling. We've come full circle. But in order to do so, the JavaScript that controls this stuff needs to be really, really fast. And that is why Houdini defines a new concept of JavaScript that is called worklets. What are worklets? Worklets are, as the name suggests, a little bit like web workers. Yeah, it's JavaScript. It's not on the main web. It has a limited API. And it doesn't have any DOM access. Also, it doesn't need any DOM access, as you might have learned by now, because the DOM is way up on that graph and worklets are on the bottom there. But in contrast to web workers, worklets do not have any event listeners. And they don't need any event listeners either, because they just run as a natural part of the rendering process. So whenever the browser needs to lay out or paint, it just runs the worklet. There's no events needed. Also, the browser can decide to run that in multiple threads. It may run 4 or 5 threads for one worklet, and it may even decide to not run it at all if it finds that it is too slow. If it slows down the rendering process, maybe it just runs it every other frame, or it drops it like every third frame, etc. So it's up to the browser's discretion to decide how many threads and how exactly this runs. And they are designed to be very fast and lightweight. So web works are designed to be very heavy and do a lot of computation and stuff, and worklets should be very fast. So in the future, we might see worklets in WebAssembly, which is the next hot thing. I mean, the next language of the web, Java 2.0, so to speak, bytecode. But for the moment, it's just JavaScript, and the browser will just JIT compile it. So let's have a look at the worklet API, or at the worklet definition. So inside worklets, you can register something. You give it a name, and then you add some class that does the actual work. So that something can be layout, paint, or animation, as we've seen. So the compositing, I'll go back to the slide. So this step basically is reduced to animations. So you can do layout, painting, or animations. Yeah. So how do you load a worklet? Well, loading a worklet does not work by just adding some script tag, because that would run it as a normal script, but we want it to run as a worklet, which has, as we've learned, a limited API. It has no DOM access, so the browser needs to create this special execution environment for that script. And this is just done by calling something worklet add module, just like you would import a CSS file, or just like you would run a web worklet. So once again, we have 3 types of worklets: CSS layered worklet, CSS paint worklet, and this animation worklet right now lives in the window object. So let's look at some examples of that. Layout is the first in the family. And you have probably seen this JavaScript library called Masonry. which takes some elements and arranges them like this. It does so using JavaScript by manipulating the DOM. So couldn't we just do this using our layout worklets? The answer is yes. This is exactly what layout worklets are for. And this is where the magic happens. I mean, all you have to do is write layout masonry in your CSS file. And you're going to have to write the worklet. Or you just have someone else write it. So you need to import this worklet. And the worklet itself reads like register layout masonry. And then we provide some class that does the work. And this class has a well-defined API that the browser calls whenever it wants to initialize or call the actual layout step. So there's 3 getters that return some properties. So this is basically just a config object that lets you run JavaScript. And then there's 2 methods that will just determine the sizes and the layout, which I'm not gonna go into the details. But you can see that this API is not too complicated. So basically, you just write this layout method. You decide where all the stuff goes, and you can reuse much of the code that has been used in the JavaScript libraries that manipulate the DOM. You can reuse the logic at least. Unfortunately, this hasn't been implemented in any browser yet, so I can't show you any demos. But you just gotta believe me that it works. It's gonna work, 2022. Next up, painting. Once all the elements are laid out, we can start painting them. And one example that I find really fascinating is this QR code. Some engineer at Microsoft actually got this running. And so his idea is, let's just create a class QR code that paints a QR code and just pass it a parameter that contains a string which will then get encoded into the QR code by this paint worklet. So let's have a look at the API. It is even simpler than the layout API, all it does is paint. It defines its input properties, which might be just this QR URL property. And you even can put more arguments into the into this place here. You can also write comma something, and this will define the API. So I couldn't find the source code of this, but I could find a video. So this is from, I think it's called Ian Kilpatrick, if I remember correctly. And he made this work in probably some custom build of Chrome, I guess. So far so good, nothing special. Width and height are working. And you can see that here's our worklet being called. And this is the parameter. And once he changes the parameter in the CSS, it just re-renders the whole thing. Ain't that cool? I really like it. I really like that. This is magic, right? Okay, and he does a bunch of more things. He can change the color. Faster. Color. Good. And this will just get used as another argument for the paint worklet. So you can do all kinds of crazy stuff with that. And I need to refocus here. Okay, this is now actually running inside my browser. So you can paint whatever you like this ripple effect here. And the API really is not much different from a canvas. But it's a really stripped down canvas object, and it's way faster than if you actually used a canvas element here. So, last but not least, there's the CSS animation worklet API, formerly known as Compositor Worklet API, or Compositor and Animation API. And this lets you, well, as the name suggests, define animations. So again, the API is really simple. You just have one method to implement, which is called animate. But other than the other two worklets, calling this is a little bit more difficult. There's no CSS involved. Instead, you just, you load the worklet. And then you define some timelines that you can then use to instantiate a worklet animation. So it is a bit complicated. I'm not going to show too much code. I'd rather show some examples. So this is something like the Twitter app. And all of this animation that you see, the little avatar here and this bar that comes in from the top, all this is done using the animation worklets. And other than DOM manipulation, this is really, really fast. So we get almost native rendering speed with those worklets. And you can play a lot around with this. There's a lot of samples on the web that Google engineers put on there. For example, stuff like this, where just elements behave, well, naturally. A little spring effect here. Really cool. So basically that's all I have, unless you have any questions. I really think the future is very exciting. We can do a lot of stuff with this, particularly with the worklets. My favorite is layout worklet and paint worklets. Really cool stuff. Yeah. I haven't prepared a good summary yet. Yeah.
Why are you looking at me? Don't have any clue.
So thank you very much. Do you have any questions?